Hey there. We're going to go over the gravity pitch gizmo. This is really intended for those that weren't in class when we went over it on Friday. And so with this here, we have basically what Newton's cannon. So I mentioned a Newton's cannon before, but this time it's just with a pitcher. And so what you're trying to do is you're trying to find the right velocity so that whenever the pitch is thrown, it goes in orbit, okay, around the Earth. And if it's not the right velocity, if it's too slow, what'll happen is it'll be thrown and crash here to the earth. And if it's too fast, then it will come way out here and reach that escape velocity. And so we're going to go through and kind of do the math and try to calculate that velocity. And then we'll test it out in the gizmo. So down here, a couple things that we do need first is we need to know the mass of the earth. And the mass of the Earth is equal to 5.98 times 10 to the 24 kilograms. And then we need to know the radius of the Earth, which is equal to 6.4 times 10 to the 6 meters. Now, one thing to make note is that whenever you have an object in orbit, let's go back up here, we just wrote down the radius of the Earth, which would be from the center here to the edge. But that's not going to be my R for this orbit. Okay, you also have to include this altitude or this height right here. So this would be the height or the altitude. This would be the radius of the Earth. And so when you go in and you're doing your calculations, you got to make sure that you include both of those distances there. So sometimes the problem will tell you, the orbit has a distance from the center of the planet, but sometimes it'll give you the height or the altitude of the satellite or whatever it may be, and then the radius of the planet, and you have to add those up. So the height here of this picture is given in the gizmos, and it says it's 1,500 kilometers. Now remember, we don't want kilometers, we want meters, so we would just add three zeros. 1, 2, 3. Now we're in meters. So the first step is to get your R. And so the R that we're going to use is going to equal the radius of the Earth plus that height. So I got 6.4 times 10 to the 6 meters plus we have the height of that picture there. And so my R is going to equal 7.9 times 10 to the 6 meters. So now I have the correct R, so we can go ahead and start on our calculations. Now the force here that we're going to label as centripetal is going to be that gravitational force. That's what's causing this thing to be in orbit. So we can set that equal to centripetal force. And my formula for this gravitational force is that Newton's universal law of gravitation. So that gives me capital G, gravitational constant, m1, m2 all over r squared. And I'm going to set that equal to centripetal mv squared over r. And if you notice, we're going to be able to cancel out a couple things. One is the mass of whatever it is that's in orbit. Okay, so we're going to be left with the mass of the planet. And then also one of these r's will cancel out. So then what I'm left with is this gravitational constant times the mass of your planet all over r is going to equal v squared. And we're solving for velocity because we want to set the velocity of that ball that's being pitched to see if we can get it in orbit. So I would take the square root of both sides. And I would be left with the velocity is going to equal the square root gm over r. Now we can just plug in our numbers. So the velocity is going to equal the square root, and I got 6.67 times 10 to the negative 11 for that gravitational constant. The mass of the Earth, we said, was 5.98 times 10 to the 24. And that's going to be all over your R that we found, which was 7.9 times 10 to the 6 meters. And when you plug that in, you should end up with a velocity is equal to 7,105.59, and that's meters per second. But if you look at the Gizmo, they have centimeters per second, or I'm sorry, kilometers per second. So we need to convert that to kilometers per second, so we're going to move that decimal place 3 to the left. So then the velocity in terms of kilometers per second should be 7.1 kilometers per second. So if our math is right, we can go into the gizmos and set that velocity, and we should have that ball go in orbit. Okay, so here's the gizmos pulled up, and we said that the velocity here when we did our calculations was 7.1 kilometers per second. There we go. And so now we'll just go ahead and hit play and see what happens. And it looks like our math was right.
Oh.
Uh-oh, he should have wore a helmet. All right, so to kind of sum up everything, remember whenever you have these orbits, you're going to set your gravitational force equal to centripetal. You can cancel out the mass of whatever's in orbit. One of your R's, just make sure that your R is from the center of the planet all the way to wherever the orbit is. So sometimes you might have to add that altitude or the height of that object that's in orbit.